So you have to have the independent variable in ask mode. If it's not in ask mode, you cannot plug in the numbers you want.
Okay.
So then you plug in 0, you get a negative number. You plug in 1, you get a positive number. So the function, any continuous function that changes sign like that, it must pass through the y-axis.
Okay.
Better?
Yeah, I got it.
Thank you.
Thank you.
Thank you. So divided by the derivative. So let me write the derivative here, which is 2 to the x plus 2x. And now we have to decide if we want to start with 0 or 1. Both of them work. How come? This is 1 plus 0, so this is 1. If you want to start at 1, this will be 2 plus 2, which is 4. So the derivative is not 0 at either point. So it doesn't matter. So now it's up to you if you want to consider this the initial value or if you want to consider the first iteration. I'm fine with both. It doesn't matter really. So which one would you like? I don't mind if you consider the first iteration, that's fine. But let's choose. We want to start at 0 or we want to start at 1.
0 is easier.
That's fine. We're not going to plug it in. The calculator will. Okay, so now I'm going to share my screen again and make sure that do not delete what you have. Do not, because this is the numerator, right? But just insert, second and insert x minus parentheses. Go to the end, parentheses, divide by, parentheses again, 2 to the x, and then plus 2x. And close. Get out of there. Go back to variables. Choose the y variables. Press enter. Select y1. We want it to start at 0. Fine. We get this. And now second end entry. And I just copy the previous answer. And I can go on forever. Just click, 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 click. Now, can anyone tell us how many decimals they want on this so we know when to stop? So if we consider x1 to be 0, then x sub 2, the second iteration, is 1. So x1 is 0, x sub 2 is 1, x sub 3 is 0.75, x sub 4. So how many decimals they want on this?
I'm trying to find it.
That's okay. It does depend if you start on the left or on the right, in the sense that you may get to the solution faster. It doesn't matter, you know how you're going to stop, so it's really not a problem. You can continue.
This is 6 decimal places.
How many?
6.
Yeah, so you can continue from here with click, 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 and you stop when 6, the first time 6 repeat themselves. That's it. So the difficult part is to enter this in the graphing calculator. That's the most difficult part, which I think it's really nothing. But if you're careful with parentheses, you should be fine. So this should, it's a problem that requires like 5 minutes at the most. Create the function. By IVT, find an interval. It has to be 1 unit interval. Present the interval. State the theorem that you are using and why. Create the function, and then click, 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 click. Good. Anything else? Anything else that you would like to go back to? Any problem, book or otherwise, web assign, or anything you tried? Or homework or anything?
Web assign.
Yes.
It's on. Actually, never mind. This one was on the 4.6.
Okay,
But there was another section. Give me one.
sure. I just don't want to show the problems. So if any of these problems was part of the homework that is due on Wednesday, I would have to change the problems. So I'm more than happy to do them, but I'll have to change the problems for grade. Was any of these from the homework that is due on? I didn't write solutions yet. So was it on the written homework that is due on Wednesday? Any of them?
Yeah,
I think
I don't know. I haven't tried it yet.
I haven't seen the written homework.
Okay.
Yeah,
the fence one is.
Okay, so I will have to change the fence one.
I've already done it. So
Yeah, I should have said that from the beginning. But I think that Sean selected it from not from the book, but from his web from his WebAssign.
Correct.
So it's not
he
this.
did, but if I already did it, I mean, can I just turn it in tonight? I didn't. You'll see. I didn't copy what you have. It's done differently, but.
But is it with the same numbers?
It is, but.
The same identical numbers?
Yeah, but is that our fault that we've done it in class? Like, I've already done it.
No, it's not your fault. No, it's not your fault. I should have asked. Anything else? Do we have other questions? So
I do have a question.
Yes, I'm ready.
It's one of the poster questions. I don't know if you did one like this.
Yes, we did one with the poster last time.
Okay.
But if you still want to do one, it's fine too.
Yeah, it's in 4.7 in the
Okay.
website.
Okay.
It says the top and bottom margins of a poster are each 12 centimeters. On the side margins are each 8 centimeters.
So you're saying that the top, this one is 12 centimeters and this one is 12 centimeters?
Yes.
Okay.
And the side margins are 8.
This one here, 8.
If the area of the printed material on the poster is fixed at 1,536 centimeters cubed.
It has to be squared.
Yeah, cubes, centimeters cubed squared. Find the dimensions in centimeters.
Find the dimensions of this, of the poster, of the printed area. Do we have these sides or not?
That's it. The same way you have it drawn is the same way it shows on the website.
Yeah, so you're saying that this is problem from 4.7. Which problem is it?
Number 10.
Number 10. So let's read it together. Let me go there just to make sure. You said 4.7. I see 4.7. Oh, no, I didn't mean that. I just want to go to the problem. I just clicked on, I just want to click on the assignment, not on anyone's. Okay. And we can change with your numbers. I don't have a problem with that. So this is problem 10. Problem 10. Oh, okay. I see now. Okay. So that's why it didn't make sense. So, so you have 10, you have 12 here, and you have 12 here, and then 8 and 8 on the sides. Okay. Okay. So is this okay for you? So I guess for some reason I got exactly the same numbers with you, right?
Yeah, my numbers are the same.
Okay, very good. So now I see. Okay. Find the dimensions in centimeters of the poster. Very good. Okay. So the dimensions of the poster are basically these, right? So this is X and this is Y. Okay. So the inside is given to us, and we have to determine this width. As you see, 8 and 8, so it must be X minus 16. And this is 12 and 12, so this must be Y minus 24. So I highly recommend look at the problem we did last time as well. Okay. So this area, which is 1536, is the same with X minus 16 multiplied by Y minus 24. So this is fixed again. We are given this information. We're asked to find X and Y. I just want to find the dimensions in of the poster with the smallest area. Okay, so we want to minimize area of the poster, knowing that this is a restriction. Okay, if I have to minimize the area, I'll make it a micron by micron. No, this is fixed, so we have to go around it. In other words, we have to take care of it, right? We have to include it in our calculations. So the area of the poster, area total, is what we want to minimize. Okay, so that is X times Y. So I'm thinking what is best to consider X and Y the inside, because I'm minimizing the entire area. I think that will be better. So I think the notation should be X and Y, and this will be X plus 16, and this will be Y plus 24. That's a better option. This is exactly, because I want to minimize X times Y, that's why. So I'm just going to graph the same thing again, but I'm going to use different notation. So this is, so this inside, this is X and this is Y. The outside, since this is 8 and this is 8, this is X plus 16. And this is, and this is 12 and 12, this will be Y plus 24. So this is given to us as 1536 centimeters squared, which is X times Y.
In your other paper, you had Y minus and X minus. Is it minus or plus?
Okay. So I said I am going to denote this by Y. Therefore, this will become Y plus 24. Twelve plus 12 plus Y is Y plus 24.
Okay.
Then I'm going to denote this by X, and X plus 8 will be X plus 16. Is that okay?
Yeah.
So now the total area is X plus 16 multiplied by Y plus 24. So when I distribute here, I get xy plus 24x plus 16y plus 16 times 24. I don't care to multiply because I'll differentiate in a minute. So from here, from this equation, I will solve for x, for y, and I get 1536 over x. So this will be replaced by 1536 plus 16 times 24 plus 24x plus 16y, which is 1536 over x. So now when I differentiate the area of x, these will go away. This will become 24. And this will be negative 16 times 1536 over x squared. Or 24x squared minus 16 times 1536 over x squared. And when I set this equal to 0, I have that 24x squared equals 16 times 1536. Or x squared is 16 times 1536 over 24, and I take the square root, and I will only consider the positive solution. So here's my calculator. So 16, so the square root of 16 times that 1536 and divide by 24, close. So I got 32. It should be plus or minus 32, but because it's a distance, it's only 32 centimeters. So we claim that this gives the minimum, right? So we're asked to find the minimum area, given the restriction that the inside is 1536 squared centimeters. So then I have to show that that gives the minimum area. So 0, 32. So total area prime, this is 0. So when I plug in 0 here, yes, I get negative. When I plug in over, it's positive. So x equals 32 centimeters, which means that the length for the base will be 32 plus 16. So that is 48. So then x plus 16 equals 48 centimeters. So this whole thing is 48. And now this, which is y, I have to find y. Y is this. So y equals 1536 over 32. And then I can determine y plus 24. So sharing my screen, and I have 1536 divided by 32. Let's see what that is. And I have to add 24. And I get 72. So this poster, in order to get the or have the minimum area with a given restriction that the inside has to be 1536 centimeters squared, has to have these dimensions. So 48 base times height. Very good problem.